Welcome to clickmeproject.com. Let us see the demo of graph-based semantic annotation for enriching educational content with linked data. We propose a new approach to semantic annotation with linked data in the field of document enrichment is presented. This application has been developed in the domain of education and contrary to traditional semantic annotation, which relates each relevant term of document with an instance of technology. In our approach, relevant terms are connected to subgraph of ontology. Specifically, each relevant term is related to instance which is expanded to predefined depth limit. So the term is finally annotated with subgraph. During the expansion process, the instance unrelated with document topics are ruled out, so only relevant and contextualized information is finally included. As a result of this process, the document is annotated with set of interconnected graphs, and students may access and navigate through these contents to deepen the topics described in the document. This approach has several benefits. From the document enrichment perspective, a set of subgraphs provides a better description. Moreover, considering the semantic nature of linked data. From the computational perspective, this approach is almost more suitable, particularly in the domain of education. In this process, first of all, we have to perform the data selection. After data selection, we have removed the stopwords from extracted data, and we have performed the stemming operation. After that, we have to calculate the term frequency for each terms. After calculating the term frequency, we have to getting the frequency threshold value. From that, we have getting the most frequent item. After that, we have to give the input to dbpedia, getting the candidate instance. After generating the candidate instance, we have applied into POS tagging process and constructing the URI of candidate instance. After that, construct the initial ontology, that is initial graph solution. After that, we have to refine the graph solution using frequency threshold value. Let us see the demo of the project. First of all, select the document edu.rdf. RDF is the resource description framework. This is the ontology format. This is the original content. This is the extracted content. After that, we have to perform the stemming for extracted content. This is the stemming contents. After that, the extracted stemming contents loaded into the database. This is the list of terms extracted from the dataset. After that, we have to calculate the term frequency for each extracted terms. This is the list of term frequency for each term. After that, we have to getting the most frequent item. This is the most frequent item. From which data we have to search from DBpedia. This is the generated candidate instance. After that, we have to perform the POS tagging process. This is the tagged instance. After that, we have to extract the terms. After that, we have to getting the relevant terms, that is noun. After that, we have to get the candidate instance. Then we have to get the URI of all instance. Next, we have to construct the ontology. This is the generated ontology for given candidate instance. After that, we have to call the protege.exe file. This is the generated antograph. This is the generated antograph for initial population. Next, we have to set the depth limit for terms. This is the depth threshold value. Submit. Next, we have to getting the refined graph solution. This is the refined ontology. Next, we have to get the final graph solution. This is the refined graph solution. Thank you.